This video is going to be looking at exercise 7E and solving problems involving compound interest. So you have the compound interest formula on your formula sheet, and this is the one we're going to be using today. So breaking it down, you don't get the definitions in your exam, so you need to know them. We know that A stands for the future value of the investment or loan. P is the principal, so the amount you invest or borrow. I is the decimal rate of interest per compounding period. So if your compounding period is yearly, then I is just the yearly interest rate. If your compounding interest is monthly, you need to convert that I value so that it represents the interest per month. N is then the number of compounding periods. So if you compound monthly, that would then mean you have 12 compounding periods every year. If you compound quarterly, 4 compounding periods a year. So that N needs to represent those compounding periods, not the number of years. So the first example we're going to look at is this one, and it says Sophie is trying to save $30,000 towards her daughter's college fund. She has $12,000 to invest. Big Bank are offering an interest rate of 8% per annum, compounding quarterly. How far off the $30,000 will Sophie be in 10 years? So, we know this is compound interest because of the crucial word in this example, which is compound. And we can see that this is going to be on a quarterly basis. So, when we're thinking about compounding periods, this needs to be converted into how many quarters there are. And we have other key information of 8%, that is our interest rate. And we are told that she has $12,000 to invest. So, using our formula, A equals P brackets 1 plus I to the power of N. We need to look at how much she would gain using this compound interest information towards that 30,000. So A is what we want to find because we want to find out where is she in 10 years time. P is our principal and she starts with $12,000. I is going to be our interest rate, and if you remember, it is the decimal rate of interest per compounding period. So we need to convert 8% to a decimal first of all, which is 0.08. And now that at the moment is per annum, which means that is per year. We need to change that to quarters because that's how this is being applied. So I need to divide this value by 4, which gives me a new interest rate per period of 0.02 or 2%. And finally, we need to work out our N. And again, our N is not years, it's the number of compounding periods. So we're doing this over 10 years. And remember though, we're compounding quarterly, so then this needs to be converted into quarters. So in 10 years there are 4 quarters. So we have a total of there are 4 quarters in each year, so we have a total of 40 quarters over 10 years. Subbing all these values in, we get A equals 12,000, 1 plus 0.02 to the power of 40. And if we work that out, we get an answer of A equals $26,496.48. So how far short of her 30,000 is she? Well, we're going to say, okay, let's do our 30,000, her target amount, minus the amount she will have if she followed this investment plan. And her shortfall then is a total of $3,503.52. So we can say she will be short that amount. Okay, the next part of the question then says, so we know how far short she'll be. We then get asked how much would Sophie have to invest to the nearest dollar to be able to withdraw 30,000 in 10 years time. So what we're saying is, okay, so she's clearly not investing enough. What would she actually need to invest in order to figure this out? So to get there, what we're going to do is we're going to have a look at our formula to begin with. So the question is basically asking us to figure out the value of P that would lead to a value of A of $30,000. So we want to end up with that amount. Our interest rate is still going to be at 0.08 on 4 because that interest rate and compounding period offered by the bank hasn't changed. And our time period N is still going to be at 10 times 4 because we're still compounding quarterly. So looking at this, then we can have a look at our formula and we can look about how can we rearrange this. So we want to make P the subject. To do that, all I'm going to do is divide by my 1 plus I to the power of N, and that will give me P. So subbing in these values, I'm going to get 30,000 divided by 1 plus 0.02 all to the power of 40, and that will give me my P value. And if we sub all that in, we get P equals 13,586.72, and so to our nearest dollar, which was what the question asked, that means she would need to invest $13,587 in order to end up with 30,000 at the end of 10 years. So she would need to invest $13,587. Okay, so that's that example done. Example number 2 then says Jamie has $20,500 and would like the investment to grow to $32,500 in 8 years' time. If Jamie's investment earns interest that compounds monthly, what is the minimum annual percentage interest rate to one decimal place that he would require in order to achieve his savings goal? So the thing it wants us to find is, because the question starts here, what is the minimum annual percentage interest rate? So this is what we're trying to find, the interest rate, which is our I value. I is now the unknown. That is what we don't know. It's what we are trying to find. So let's think about what information we do have. We have Jamie has this much money, so that there must be his principal. We are told we know he wants to grow this to this amount, so that must be his final amount. Now, we have this time period of 8 years, but we need to be a little bit careful because remember, N isn't just the number of years, it's the number of compounding periods. So if we compound yearly, then N would be 8. But if we remember from the question, it actually says that this deal that he's looking into is going to compound monthly. So we need to bear in mind that N then is going to have to take that into consideration. And I will have that same consideration involved as well. So our formula, we have A equals P brackets 1 plus I to the power of N. We know that A is 32,500. We know our principal is 20,500. We know I is what we want to find, and we also know N because we know it's 8 years that he's doing this investment for, and that the compounding periods are monthly. So N is the number of compounding periods, which will be 8 times 12, which is 96. So we have all the information we need. We now just need to work out, well, how do I rearrange this equation here so that I is the subject? Well, the first thing we're going to do is we're going to divide the equation by P, and that means now I have 1 plus I to the power of N. Now, to get I on its own, we first of all need to remove this power of N. To undo a power of N, I apply the power of 1 on N to the other side of the equation, and that removes that power. Finally, to isolate I on its own, I need to remove -1. So I'm going to get A on P to the power of 1 on N, subtract 1 equals I. And that's how you would rearrange the formula in your exam. So putting all this information in and solving our problem, we now are going to substitute in the values. So we get I equals, and it will be 32,500, because that's his target amount, A, divided by 20,500, his principal. all to the power of 1 on 96, because that's 8 times 12, the number of compounding periods, then subtract away 1. And when we do this, we get an I value that comes out on the calculator as 4.811 times 10 to the negative 3. And this is just in standard form. So what this actually means is you have 0.004811. So remember though, at the moment, I, if we go back to those definitions, I is a decimal rate of interest per compounding period. So this, if we go back to this question, it wants us to find the annual percentage interest rate. So I'll just highlight that. It wants us to find this. At the moment, our interest rate is per compounding period. So this interest rate down here is actually the interest rate per month, because this is per compounding period, so our compounding periods is month. So this is how much interest we earn per month. So to convert that back to how much interest we'd have in a year, we need to multiply our value by 12 to convert it back. So if we multiply this by 12, we get a decimal of 0.0577. And don't forget, this is the decimal rate. So to convert it back to a percentage rate, we then just multiply by 100, or you can just convert it in your head, and we get 5.77%. And I believe this asked us to give the answer to 1 decimal place. That's what it says over here. So converting that to 1 decimal place, we can say that the interest rate that would be needed would be 5.8% per annum, because that's the annual rate.